This video is all about quadratic equations. The first part of it is when it comes to graphing a quadratic equation. You often see the equation in two forms. First, you have standard form, which is this y equals ax squared plus bx plus c. That's probably the one you're more used to, where you can find the axis of symmetry by doing negative b divided by 2a. You can find the vertex by then plugging that back in. This is probably what you're used to. Vertex form is actually easier when it comes to graphing because the vertex happens at the coordinate point h comma k. Okay, so if you're graphing this, if you can look at what number is in the spot for h and what number is in the spot for k, that's going to be where the coordinate point of my vertex of my parabola is going to be. Okay, and remember that a value out front, regardless of the form, the a value out front tells us how stretched the parabola is, whether the parabola goes up or down. So if that a is positive, it goes up. If it's negative, it goes down. That a value tells us a lot. So after that, we're going to get into solving quadratic equations. And there are basically four things you need to know about solving quadratic equations, or four different ways to do it. The first way is the zero product property. This is probably the way that you're most used to doing this. And that is, if you have a quadratic equation, you want to get it set equal to 0. And then you want to see if you can factor the left side, and then set each one of those factors equal to 0. So what we're looking for here is two factors that would multiply to negative 24 and add to positive 5. So that would be positive 8 and negative 3. And then the zero product property says that I can then set each one of those equal to 0 and solve. And so what I'm getting here is x equals negative 8 and x equals 3. The next way to solve quadratic equations is by taking square roots. The only way that you can solve by taking square roots is if your b term is missing. So I don't have this middle term here that just has a linear x to it. I've got the quadratic term. But if that middle term is missing, you can simply just move your constant term to the other side of the equation. So we have x squared equals 36, and then we can take the square root, and we would get that x could be positive or negative 6. Now if it's in vertex form, which this next one is, I could solve by taking the square roots in this case, because what I can do is just take the square root of both sides right away. So I would have x minus 4 is equal to positive and negative the square root of 5. Now if that was a perfect square, I would go ahead and take the square root of that, but I would still have positive and negative, whatever that number would be. And then I could add 4 to that number. So here I'm adding 4 to positive and negative the square root of 5. And the best that you can make that look is to put your whole number first, and then the plus and minus, and then the square root part. So x could equal plus and minus the square root of 5. I'm sorry, 4 plus or minus the square root of 5. Okay, so zero product property, square roots. The last two are completing the square and quadratic formula. These two can both be used anytime. Anytime you have a quadratic equation, you want to solve it, you can use either one of these methods. You're probably more used to the quadratic formula. I'm going to go through completing the square because we are going to need to know this later on in pre-cal. But when you complete the square, what you want to do is keep the x terms on one side and actually move the constant over to the other side of the equation. So I'm going to subtract the 13 over to the right side of the equation. Now that's completely different from when we use zero product property, right? We want it equal to 0. But with completing the square, you want to move your constant to the other side. Then what you're going to do is you're going to find a new constant to put on this left side that's going to make this be a perfect square trinomial on the left side. Get more into detail on that in just a second. So how am I going to figure out that new constant? What you do is you take your b term, which is negative 8 in this case. I'm going to divide it by 2, and I'm going to square that. And that's what I'm going to put here. So negative 8 divided by 2 is negative 4. If I square that, I get positive 16. Now I also need to add that to the right side of the equation so that I'm not changing the value. I'm going to add the same thing to both sides. The reason you do that, again, is so that the left side of the equation factors into the same thing twice. Okay, so that means it's a perfect square trinomial. So the left side, what multiplies to positive 16 and adds to negative 8, is negative 4 twice. X minus 4, x minus 4. That is because we knew what number to put here, right? So we have to get that to happen. On the right side, negative 13 plus 16 is 3. And now I basically have what I had going on here, right? So my next step would be to take the square root of both sides. I would get x minus 4 is equal to positive and negative the square root of 3. And then I'm going to add 4. And I would get that x would be 4 plus or minus the square root of 3. And then quadratic formula, hopefully you remember this. This is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in plugging those values in, x equals negative b. b is already negative 5, so that's going to be positive 5. Plus or minus the square root of b squared, so negative 5 squared, which is going to be positive 25. That number should always be positive there. Minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a, so 2 times 3. So continuing to work this down, 5 plus or minus the square root of 25. This would give me 12. Negative 12, but I'm subtracting that, so that's going to turn that into plus 12. And on bottom we have 6. So x equals 5 plus or minus the square root of 37 divided by 6. Now that's actually as far as I can go on this problem, but I want to have a little discussion here. If this is not a perfect square, you should look to see if there's a factor that you could factor out that is a perfect square. So, for example, if that was 24. 24 is not a perfect square, but 24 has 4 as one of its factors. It's 4 times 6. So I could bring out, I could make the square root of 24 be 2 times the square root of 6. And then I could reduce this down a little bit. If this is a perfect square, obviously you would want to take the square root of it, and then add that number to 5 and divide by 6, and subtract that number from 5 and divide by 6. So there's a lot of different things that can happen here. Also, if that number is negative, hopefully you remember if that number is negative, that means that there is no solution to this, because those would be imaginary solutions, which we will get into that later on if you don't remember. So solving quadratic equations, as easy as doing the zero product property or taking square roots, could be as complicated as doing completing the square. With any quadratic equation ever, if you want to use the quadratic formula, you can do that and you will get to your final answer.